The ANOVA test can be used to compare the means across more than two groups, more than two levels of a categorical variable. And what we've seen is that we run a test and see, is it statistically significant for the null hypothesis that they're all equal? And then if it is significant, where is the difference? Let's look at a more complicated example than when we first saw. These are some real data. These are older data, but does the average amount of hours spent at work differ for people with different education levels? And we could spend a good amount of time. The first thing you always do is look at your data. And if you look at these data, you would have some really interesting questions. The first is, who are these people who don't know how much education they've had? That's very interesting. Who are these people who say, how much education have you had? It's not applicable. That's weird. Well, I guess it's not weird. Maybe they just went somewhere where they don't do education in a way that we do it with these data set. You might look at these data and say, oh man, why am I in graduate school? I'm going to work more per week, it looks like, than the average person who has a high school or diploma or whatever. You also might look at these box plots and think, it's a 5-number summary, right? The median is in the middle, 25th and 75th percentile. The whiskers go to the most extreme points unless they're outside of a certain range, and they get labeled as, I don't like the term outliers, but they get labeled, right? So we can see that those are the values. But if I look at these groups, it's almost like a 4-number summary. Something's missing. Pause it for a second. See if you can figure out why those boxes look like that. The boxes look like this because if you ask people, how much do you work on the average week? Most people work 40 hours a week. So many people work 40 hours a week that's the median. That's the average. And so many people work 40 hours a week that not only is the average, but it's also the 25th percentile. So that median is right there in the bottom of all those boxes. Let's run an ANOVA, though, and see if the mean is different between the groups. Are all the means equal? Here's our ANOVA. One way. There's another typo in this slide. When these slides got converted into PowerPoint, there were hyphens that were added. And so this should be one word instead of one way. One way, and then the outcome, and then the independent variable. And we make this table, and here we see that if you look at the difference in the means between these groups, it is significant. There is a statistically significant difference in the number of hours that you work per week based on your education category. Good. Now, if you told somebody that, hey, I'm going to go to graduate school. Well, you know, when you change education, that was causal. People in different education categories work different number of hours per week. You would say, oh, this is the best. Anytime you're in a conversation, just say this. Ooh, tell me more. Tell me more. Well, okay. Am I going to work more or less? What's going on here? And so the follow-up question to ANOVA is like, where is the difference? Where is the difference? And as we saw, once we know that they're not all equal, we can run all possible t-tests and see where those differences are. Now, this looks a little overwhelming. There's a lot of t-tests here, and most of them are not statistically significant. There's one here, graduate versus less than high school. There's one here, bachelor in high school. There's one here, relative to your friends who have a high school education. You are going to work more on average per week than they are. It's not that much. It's only 3.5 hours per week. And there are 52 weeks in a year, and you'll probably work, 40 years. So maybe that is a lot. And there's also a difference here in graduate versus junior college. Now, can you summarize this in one English sentence? It gets a little hard to summarize it. Now, there's a way to do it that you'll often see in the literature, and it looks like this. You make a table. This is called tabulate. And what you can do is plug in the means. These are the numbers. Less than high school was 45. High school was 45. Junior college was 46. Bachelor was 47. And graduate was 49. Now, we make these numbers in the table, and then we add this little interesting thing at the bottom. It's a little confusing because it's a negative, but what we're going to do is add symbols to these numbers. And if two of those numbers have the same symbol, it indicates I ran a t-test and they are not different. And I'll show you how this works. I'm going to go back a slide. Let's look at less than high school versus high school. Let's look at that t-test between those two groups. Here's high school versus less than high school, and you see that it is not statistically significant. P is greater than our alpha of 0.05. And, we can even confirm that if we look at this confidence interval, which includes the null value. You'll notice there's a new word on here, unadjusted. And that's a little teaser for what the next slides are going to talk about. The confidence interval includes 0. P is greater than 0.05. There's no significant difference than high school and less than high school. So when we make this table, we add a symbol. Let's use this symbol. That's the letter A, right? That's the letter A. What about junior college in less than high school? Well, junior college in less than high school, that's here. Junior college versus less than high school. It's also not statistically significant. And junior college versus high school is also not statistically significant. So that can get the same letter, A. If we put an A here. And so when you look at this table, you can see that 45 here and that 46 here are not significantly different from each other. All right, so what about bachelor in these other groups? Well, 47, let's see. Let's look for bachelor on here. Here's one. Bachelor versus high school. Statistically significant. So can bachelor get a letter A in here? It can't, because can't have the same symbol that high school has. Well, we need another symbol. Okay, let's try this one. We'll put a letter B. And you look at this and you say, okay, well, bachelor and high school, they don't share the same superscript, so they're significantly different. And then we would have to say, what about bachelor in less than high school? Now, I don't want to go back and forth and do this whole sort of thing, but bachelors work more than people who are less than high school. Wait, let's double check. Bachelors versus less than high school. Bachelor versus less than high school is the same. So now less than high school has to also get that B, so that when you look at the pairwise comparison, they share the same superscript and they're not significantly different. I'm not going to go through all of this, but you'll find out that we'd have to put a B here. And then when we get to graduate, it's interesting because graduate school versus junior college is different. Graduate school versus high school is different. Graduate versus less than high school is different. So you might think, oh, that's fine. Graduate doesn't really need anything because it's different from everybody. But this pairwise comparison, graduate versus bachelor, dang it, they're not significantly different. So they have to share a superscript. Well, we could add another symbol, C, like this. Now, we did that by hand. I know it's a little bit confusing. There are programs that will do this for you, and they will add the appropriate symbols to show you which of these pairwise comparisons are statistically significant. Doing it in a table can display the information much more efficiently than trying to put it into a big English sentence. You will see this in the literature, so get comfortable with this example.